Hello, everyone. So today's topic is multiplayer programming with Unreal Engine 4. I'm going to focus more on the C++ type of implementation, but the majority of the functions that we're going to use are applicable to Blueprint as well. So my name is Viktor Ketipov, and I'm the founder and lead programmer at Kipi Interactive. We are developing CryoWar, which is a real-time multiplayer arena brawler. And here's a GIF of what the game looks like. We're also developing our own internal tech that is on top of Unreal that helps us develop games more reliable and faster. So what I need you to know is that multiplayer is specific for the certain type of games. And I'm going to talk to you from the perspective of building an arena brawler. And what is multiplayer basically? A lot of clients sharing information through the internet. So they're sharing information about what's happening in the world. And there are several models that you can use. So the first one I'm going to share with you is peer-to-peer, where every client is connected to everybody else, but there's no single one authority. So every client could be connected to everybody else, but also it's not really necessary as long as there is connection between every player. It could be through one hop, it could be through two hops. The main advantages of peer-to-peer is low latency. So if me and my friends are in the same room or in the same building, then sharing information about, for example, what I'm doing with my character in my game doesn't take a lot of time to get to all the clients. But the big problem with peer-to-peer is actually because there isn't authority, it's a lot easier to cheat. Because if I say that I'm moving with, let's say, 100 meters per second, where my maximum speed is 50 minutes per second, then it's harder to justify whether I'm cheating or not. Another way to transfer data is when you have an authoritative server, meaning that there is one server that actually simulates the whole game, in most cases without any graphics, but everything from where all the characters are located to whether someone is in low health, does it have cooldowns on their skills, and so on. So the big benefit of client-server architecture is that you have an authority that simulates the whole game, and it can tell you if something is right or not. And that gives a lot of advantage with cheat prevention. Unreal supports client-server architecture by default, but since it's source available, you can also implement peer-to-peer architecture. On this talk, I'm going to focus on client-server architecture. So, what are the general issues with multiplayer programming? First off, it's establishing connection. And this is mostly true in peer-to-peer, because some clients might be behind a NAT, meaning that some clients might be behind a router in a private network, and establishing connection could be difficult. There are different techniques to overcome this, but generally that's an issue. And it's an issue because sometimes you want to use one global IP for your whole local network, but mostly it's because the amount of devices that would require a unique IP is larger than the amount of IP addresses that can be in the current implementation of IP version 4. While IP version 6 would solve this problem, there's still time until that happens. So this is a solvable problem, and it will take time until we actually solve it. But there is another issue that is not going to be solved in the near future, and that is latency. No matter what you do, you always have latency when sending information to somebody else. So no matter what we do, there's still going to be that physical latency of sending information from here to somewhere else. And here's an example what could happen in your game. So you want to activate a skill, but you don't want to give the authority to the client. So you actually have to request to activate a skill. This is an example, of course, from CryoWar. You want to activate a skill, but you don't want to give the opportunity for a player to actually activate skills anytime they want. So you want to have some kind of cooldown. But checking the cooldown means checking the server, and that requires time. And also, when you want to activate skill, it takes time to get to the server, and then it gets delayed even more when it gets to every other client. So what do? One option is when we want to activate a skill, we actually start using the skill animation. And if we are sure and there is a confirmation that the skill can be activated, then we actually just proceed as usual. But even in this situation, every other client is actually going to receive this information later than we actually initiated. So whenever you're thinking about multiplayer game, always know that there is a latency between you click a button and everybody else actually receives that information. The good thing is that latency is becoming lower, but also we are getting better at hiding it. And there are several techniques for doing that. So how do you implement multiplayer in Unreal Engine 4? But before we start, we need to talk about ownership. So every client owns its player controller. And any object whose outermost owner is the current player controller is also owned by the same client. What that means is that, for example, if you have a HUD and a health bar, the widget health bar will be owned by the HUD, which will be owned by the player controller, which makes sense because your HUD in your own player actually shouldn't be replicated in any way to everybody else. It's just an information about you. There's also roles regardless multiplayer. Role authority means that the current actor actually is full control over the object. This would be the case if you actually spawn something. Simulated proxy means that you're not an owner of this object, and what you're seeing is extrapolated based on the last known velocity. Autonomous proxy means that you're also not the owner of the object, and the information you see is extrapolated based on some kind of input. Usually, you can always have just one role of the current actor, and autonomous proxy is usually used for other players because we know what they're actually doing at the moment because they're sharing that information. Now, imagine that you're building an MMO and your whole game takes place in one gigantic building. Let's say an island. Everything that you don't see as a player is not actually relevant for you. If you try to share the information of the whole world, that's going to clutter your network because that would be a lot of bandwidth. So you can actually make this better in two ways by overriding isNet relevant for. And what you can do is just not replicate any information that's too far away from the player. Sometimes, even in a small area, you might have a lot of data to be replicated, and that's where net priority comes in place. You can actually prioritize different actors that are more relevant for the player. For example, if you're fighting some creature, then that creature is actually needs to have a higher priority, because if you hit your network bandwidth, you want to make sure that you're still, the most important information is actually still transferred to your players. And this whole thing is actually really important, especially if you have some bandwidth limits, for example, a mobile network. Now, how do we actually replicate information? Unreal has its own replication system for synchronizing primitives. It's used by actors, and U objects are not generally suited for replication, but you can actually assign a U object to an actor, and the actor can replicate that U object as well. So how do we do this? So first off, let's start off with health, simple health. We need to use U property, replicated, in order to identify that this property is going to be replicated. Second, we need the actor to be ready for replication. And third, we need to override get lifetime replicated props. So here we use do rep lifetime with the current property, which means that no matter what, this property is going to be replicated. You can have actually additional conditions whether to replicate a specific property, which gives you a little bit more granularity, not only what actors in different scenarios to be replicated, but whether some properties of a specific actor to be replicated. One cool feature of replication is RepNotify, which gives you a notification to each client when something has changed, when something has been replicated. And that's very useful in cases where you want to do something when you receive an update. For example, you equip an armor, and then you want to activate some glowing effect. When you use RepNotify, you have a declaration of a function starting with onRep and the name of the property. You have to write it in your CPP file. You can replicate components by calling component set is replicated. Another way to sharing information through different clients is through remote procedural calls. It has three different arguments: to whom you're sending, to client, to server, or multicast. Typically, if you're sending it to a client, you're a server. If you're sending to a server, you're a client. And if you're sending multicast, meaning to every client, you're a server. Reliability, whether whether this RPC is reliable, meaning that if it gets lost, we'll send another one until we can confirm that the RPC is sent and actually is received as well. And validation is used to prevent cheating. So you can have some validation of whether that client actually is not trying something phishing. And let's give some examples. So let's say we want to equip an armor. We use U function. We send it to the server, reliable, and with validation. Our function is called equip armor. And what Unreal will do is it will create the declaration of equip armor _ implementation. And here's where the actual code comes in. So when you call equip armor, then the implementation will be here. Since we have with validation, we also need to implement _validate, which returns a bool. So we need to return whether this is validated or not. Just to point out here, you have to be really careful and make sure that you are absolutely certain that you return the right value, because if you return false, you're actually going to kick that player. So you have to be absolutely sure that someone is cheating in this scenario. And An example of unreliable RPC. So let's say you want to spawn a particle and everyone wants to see it. It makes sense to send it as a multicast from the server. We don't want to be reliable because let's take one example. You shoot a fireball and it hits somewhere. The fireball disappears and you send an RPC to spawn some kind of particle. But the packet gets lost. And if it gets lost and we send another one, then let's say 100 milliseconds later, the particle is going to appear. So players will be confused. Well, what happened? I mean, the fireball hit, we did receive damage, we didn't see a particle, but then we saw another particle. Is it a second fireball? Did the second fireball fire, or there's some kind of lag? So we use unreliable RPCs when we care about action that is just for that particular moment. If it doesn't get to the end, then we don't really care about it. There are a few gameplay classes that you need to be aware of. Game mode exists only on the server, so you should put all your really important logic there. For example, what happens when someone dies? What happens when you do a damage to a different character? No client has any way of knowing what happens in the game mode. A game state is something similar, but it's still owned by the client, by the server, but it's replicated on every client. It's a good way to store information like how much more time is left and what's the score currently. Player controller is controlled by every client and replicated on the server. The server has copies of each player controller, so that's the kind of the easy way to share information from the client to the server. And a player state is also owned by the server, replicated on every client, and it's a good way to store information like what's the current latency of that player, what's the name of that player, and additional information. Now, tips and tricks. So, starting off, it's really important to start your game with multiplayer in mind, because then adding multiplayer might mean just rewriting half of your code. So start with multiplayer in mind. And the second one is don't be scared to execute code on the server. What I see is a lot of people try to get a really efficient network code from the first time. Don't be scared to execute code on the server. It might be slower, but the most important quality of a network game is actually being synchronous. So don't be afraid to put code on the server, even if it's got latency at the beginning. You can improve it and implement some modifications in the future. You will have a lot of issues with order of execution because you have no guarantee whether sending information to clients and servers that they're going to appear at the right time. Sometimes packets get lost. Sometimes packets get duplicated. So my advice is to be a bit more defensive and always check whether a U object or an actor isn't actually no pointer or is going to be destroyed. Now, we talked about replication and RPCs. So what's the difference? I mean, there are two ways to share information. RPCs are really good for time-sensitive events because when you send an RPC, that happens immediately. So it gets sent immediately. It's got an overhead, so don't send RPCs all the time, but send RPCs on time-sensitive events. Like, I want to activate a skill. You want to get that information as fast as possible. Replication, on the other hand, is better when you want to share information and actually package it in a more, in a better way. if you have a lot of information, the replication system actually acts on certain network ticks. So the information is not sent right away, but the information is packaged quite nicely. So use RPCs on time-sensitive events, use replication everywhere else. You can test local multiplayer in your editor by just clicking the number of number of players, increasing it from 1 to more. If you don't have a dedicated system, a dedicated server, one of the players is actually going to be a listen server, meaning it is going to be a server and a client at the same time. But testing locally is not ideal because you won't have any issues with internet like lag, loss, duplication, and order of execution. Luckily, you can use console commands, packet lag, variance, loss, duplication, and order in order to specify and actually try to simulate a real environment and see how your code actually performs in certain scenarios. But that's not ideal. Always play test multiplayer with real players. You have no idea how players are actually going to play your game, and you'll find a lot of exploits just by playing several games, just by getting your game in the hands of several players. Okay, time for questions. Let me check the questions. Can you make a whole multiplayer game on blueprints? What are the advantages of writing C++ code instead of using pure blueprint? Yes, you can make a whole multiplayer game on blueprints the same way you can make a whole game, even a single player game, just with blueprint. The main difference is that, for example, you can't use is net relevant for. It's not implemented in Blueprint yet, so you can't make more precise optimizations, but you can still use Blueprint for that. Is it possible to have a hybrid setup combining peer-to-peer and a central server? Any examples? Anything is possible, but I really don't think what would be the benefit for it. So if you try to lower the latency by having some players actually exchange information between them, you still run with the issue that some of them might be cheating. What you can do is have different servers on different places around the world. So, and then they can exchange information on their own, but you need an authority. The big problem with peer-to-peer is that you don't have an authority, you don't have someone to trust. And you should always be careful in that situation. You should never trust the client. Do we have time? I think we have time for a few more questions. All of this is embedded in Unreal Engine 4. Yes. Is there a possibility of dedicated server? And any dedicated server hosting that you would recommend? Yes, actually, you can use a dedicated server by clicking here. Any dedicated server hosting that you would recommend? So we have experience with PlayFab and with Amazon GameLift. Both of these provide APIs for server scaling, so that if at day one you have, let's say, 10,000 players trying to join your game, they have APIs to actually scale your servers and have a lot of enough machines to actually handle multiplayer. But there are other solutions as well. So you're not just limited to cloud services. There are also bare metal options. Okay, when building multiplayer game, especially if it's not MMO, you should be sure that players will not get any access to your server code. Server code has Unreal some mechanism that can help you avoid putting server code to clients to prevent reverse engineering of server code. Yes, everything that is part of the server code should not be shipped to the clients, and they wouldn't have access to, let's say, game mode, which is used by only by the server. Okay, but our time is up. So thank you for your time. You can find me on Twitter or by email. So yeah, thank you for your time and bye-bye.